Okay, so we're going to start out this week looking at section 3.3. Remember, in chapter 3, we're talking about rational functions. Okay, so that means you've got a function, you've got a fraction, that's a function, and there's a polynomial on the top and on the bottom. So we're going to talk a little bit more about that today, and I'm going to kind of show you some things that are simpler with regular numbers, and then we're going to apply that idea to like polynomials. All right, so I'm going to have this up a couple times this week. Just a reminder that if you have a 0, okay, that is also called a root. Right? Basically, it means that if you take the value, plug it into your function, you're going to get 0. So it's a number you can plug in for x and get 0 for y. Did anybody remember what a root is graphically? It's where the graph does what? Yep. It's where it crosses the x-axis. Yep. I'm not going to write that one down, but that is another one. And this statement has the phrase IFF in it. Okay? From logic, IFF means if and only if. What that means is you can read the statement forwards and backwards, and it's true both ways. Okay? If I read it forwards, if you have a number that is a root, then you can plug it into your function and get 0. Or you can read it this way. If you tell me a number that you can plug into a function and get 0, then the number that you gave me is a root. So you can read this statement forwards or backwards. And it's true both ways. In geometry, you learn that's called the converse, when you switch the if and the then. Okay, so what we're going to be doing is we're going to be using long division. Okay, we're not going to be doing long division with regular numbers. Okay, we're going to be doing it with polynomials. But I'm going to show you an example of what we're going to do with numbers first. So you kind of get the idea. And then we'll do it with polynomials. All right. So let's say I wanted you to factor the number 12. And I tell you one of the factors. I'm going to tell you 3 is a factor. What could you do to get the other factor? If you want to factor the number 12, you know 3 is a factor. What can you do with it to get the other factor? Yep.
Divide 12 by 3.
Right. So by me telling you 3 is a factor, I'm telling you 3 times something is 12. Your goal is to figure out the something. Like Jared just said, to figure out what it is, divide both sides by 3. And using division, you get 12 divided by 3 equals 4. Now you know what to put right here. What do you call the answer when you divide two things? Begins with a Q. It's the... Zach? Yep, it's the what? The quotient. So, if you're trying to factor something, and you know that something is a factor, and you want the other factor, it's the quotient. Okay, you got to use division to find it. Now, the key, and the way that you know a number is a factor, is when you do division, you get a remainder of 0. Right? If I took 12 and divided by 6, I would get a remainder of 0. That means that 6 is a factor of 12. If I took, let's say, 13 and divided by 5, do I get a remainder of 0 when I do 13 divided by 5? Well, right? No, what's my remainder?
3.
3. So if you do this, you get 2 remainder 3. That's one way to write the answer. The other way you can write the answer is like this. We're going to talk about this too. Quotient plus remainder over divisor. So 13 divided by 5 is 2 plus 3 over 5. And normally you write that as a mixed number, like 2 3/5. Okay? So when we don't have a remainder of 0, I'm going to show you guys 2 different ways to write it. We're going to do that with polynomials. But when you do get a remainder of 0, it means you found a factor. So that's important. Keep that in mind. That's what I just told you. So if you divide two numbers and get a remainder of 0, then you know what you divided by is a factor. So why we end up doing factoring, we're not really going to see as much of it today, maybe a little bit, but we're really going to see the reason why we do factoring tomorrow. Factoring makes it easier to find the roots. Another way to say that is factoring makes it easy to find the numbers you can plug in for x and get an answer of 0. So that process that I just showed you guys with the number 12. I told you a factor, we use division to get the other one. We can do the same thing with polynomials. And what I'll do is I'm going to give you guys the process for dividing polynomials. It's not as easy as just 12 divided by 3. It's a little bit more involved. But I'll show you how to do it. What I'm probably going to do is I'm going to write a step, and then I'm going to show you the step in an actual problem. So, when we do the division algorithm, I would leave yourself, I don't know, it's going to be 5 steps. So maybe you want to leave yourself 6, 7 lines. Some steps are shorter than others. But if you leave those lines, then you'll have enough room. Okay? And then below that, you can put a problem I'm going to give you. So this is the first step. Okay. When you write out a long division problem, this is your dividend. This is your divisor. So if the dividend is missing any terms, we got to fill in zeros. And if you're like, why do you have to fill in a 0 if it's not even there? Does it matter? Yeah, because you're gonna have columns. Okay, and you've got to have every term represented, every power. Okay, so let's look at our problem. In my problem, is my dividend missing any powers? Which power?
The second power.
The second power. I'm missing the x squared. So before I even start this problem, if I don't do this, it's wrong. Fill in 0x squared. Okay? Whoops, I'm sorry. Put it in the wrong order. So x cubed minus 0x squared minus 8x plus 3. It doesn't really matter if you put minus 0x squared plus 0x squared. What's the difference between plus 0 minus 0? It's just 0. Okay, put it any way you want. That's how I did it. Okay, so step 1. Step 2. Divide the first term of your divisor into the first term of your dividend. Okay, so divide the first term of the divisor, the thing on the outside, into the first term of the dividend, the thing on the inside. Okay, so let's look at how that would look. So, if I go back to my problem, how about, Eric, what is the first term of my divisor?
3.
Negative 3 is the second term.
X. So X.
X. There's the first term of my divisor. Zach, what's the first term of my dividend?
X.
Yep. So we're going to divide x into x cubed. So off to the side, if you want to think about it, this is what you do. What's x cubed divided by x? Yeah.
X squared.
Yep, x squared. That's the second step. Okay, I've divided the first term of the divisor into the first term of the dividend.
Is that how you write it?
Yes? Yep.
With it like above?
Doesn't matter where you put it up top here. What's going to matter is what I do next as far as lining things up nicely. You can put it. You can put the x squared anywhere you want up above. Yep. Okay, third step. Take the answer that you just got. That's actually step 2. From step 2, and multiply it by each term on the outside. And now we have to line things up in the right columns. Okay, so multiply the answer from step 2 by each term in the divisor. Put the result under the appropriate column. So what we're doing here in this last step, we're lining up like terms. Okay, so let's look at that. So multiply answer in step 2 by each term in the divisor. Here's the answer you got in step 2, x squared. You're going to multiply that out to each term. And put the term in the correct column for like terms. So let's start with Chris. What's x squared times x? Yep. And Nakara, what's x squared times negative 3?
Negative 3x squared.
Yep. And that's it. That's it. Okay, so now we've multiplied it back out. And does anyone remember the next thing you always do in long division? Divide, multiply, subtract. Right? Pattern in long division is always divide, multiply, subtract, bring down.
Did you go back?
To the problem?
Yeah.
Yep, we're going to go right back to it. So now step 4 is to subtract. Now, when you do regular long division with numbers, you only got 2 numbers to subtract at this step. Well, you're subtracting polynomials. So you're going to usually have multiple things to subtract. Okay, so subtract the columns that we just created in step 3. Okay, so the way I remember to subtract it is I would go like this. Put a minus sign, put parentheses around that. Because you're subtracting both of those. So Elias, when I subtract the first 2, what do I get in that column? 0. If you don't get 0 in the first step, you did something wrong in the previous steps. So x cubed minus x cubed is gone. Now we've got 0x squared minus 3x squared. So Sam, what's 0x squared minus negative 3x squared?
3x squared?
Yes. Okay. And I called what we just did there is basically one round of long division. We have to keep going until this exponent is smaller than that. Each time you do a round of division, your exponent is going to drop. Sometimes it'll drop by 1. Like this went from 3 down to 2. Sometimes it'll drop 2 numbers at the same time. Okay, it depends on the problem.
So you just...
But that's step 5. So I'll do that in a second. I'll bring down the next term. And then we keep repeating it basically until one of 2 things happen. Either you get a remainder of 0, in which case there is no remainder, you're done. Or you keep going until what I showed you. The degree of your remainder is less than the degree of your divisor. And we'll repeat this process. One thing that's kind of a pain on paper with long division is you need a lot of room down and to the right of your problem. Don't start a long division problem on the right edge of a piece of paper. It's going to be bad. Start it as far left as you can. I mean, depending on the problem, it's not going to go really far to the right. But you're going to see as I continue this problem, my work is basically going to keep going down and to the right. Okay, so bring down the next term. 8x. Okay, now, divide x into the first term again. What do you get if you divide x into 3x squared? Caleb? What do you get if you divide x into 3x squared?
It'd just be 3x.
Yep, just 3x. So divide it in. Now multiply it back out. Emily, what's 3x times x? 3x squared. And 3x times negative 3. Yep. So we multiplied it back out. What's my next step that I'm going to do with these columns? Subtract, put it in parentheses so you don't forget. You're just subtracting the whole thing. Brianna, what's 3x squared minus 3x squared? 0x squared, it's gone. There goes your term with the highest exponent. So now your exponent's going to go down again. The highest one is gone. What's negative 8x minus 9x? Brandon?
It's 1x.
Yep. Just 1x or x. And now the degree on this is a 1. The degree on this is a 1. They're the same. They're not, it's not smaller yet. You have to keep going until it is less. Okay, so do it one more time and this will be our last step. Bring down the 3. Okay, but now you can kind of see my work is it's kind of going down and to the right. Jacob, what do I get when I divide the first term here into the first term here?
You just get 3. Over.
So you're doing the first term x into x.
Oh,
1. Now, if the directions just said find the quotient, you're done. The quotient is x squared plus 3x plus 1. The directions said divide. Divide means find quotient and remainder. So now multiply the 1 back out. Zach, 1 times x. And 1 times negative 3. So we multiplied it. And Nikara, what do I do with those columns?
You just cancel them.
Subtract them. And we're going to see that some of it cancels out, but not all of it. X minus x, that's gone. What's 3 minus minus 3?
6.
There's your remainder. Okay. So, how do you write your final answer? Well, same way I wrote the final answer. Right here. There's 2 ways to do it. We can write quotient and remainder separate. Let's do it that way first. So quotient, remainder. Quotient is x squared plus 3x plus 1. Remainder 6. That's fine. Or you can write your answer as quotient plus remainder over divisor. That's another way to write an answer. That's just from long division. And I did that right here. Quotient plus remainder over divisor. Let's do it that way. Quotient plus, now it could be minus remainder if the remainder was negative, but if the remainder is positive, it'll be plus. Plus remainder over my divisor. That's another way to do it. The nice way about the second one is you can check your answer. I'll show you how you can check it.
Can you go back to the steps?
Yep.
Number 5.
So the way we can check the answer is type in the original problem on the calculator, and then type in our answer. And if they look the same, then that means you did it correct. So let's take a look. So the original problem was, probably going to need parentheses, so just keep that in mind. X cubed minus 8x plus 3 divided by x minus 3. That's the original problem they wanted me to do. Now, I'm going to type in what I think the answer is. So I think the answer is x squared plus 3x plus 1 plus 1 plus, I'm going to need parentheses with that fraction. Let's try 6 divided by x minus 3. So it'll do x minus 3, and then it'll do 6 divided by that. Now, if this answer is correct when I hit graph, how should these two graphs compare to each other?
Shouldn't they be the same?
They should be the same. If they're not the same, then either I type something in wrong or my answer is wrong. There's the first one, that's the original problem. And there's my answer tracing in red. It traced right on top of it, which means my answer is probably the same as the original problem. A graph can never be used as a proof. But since they look the same, I think that our answer is correct. Okay, we probably did all this work correct.
Could you go back to where you wrote that equation?
So that's how you'd want to type it in. If you forget a parenthesis or something like that, it's probably going to really mess up. And I would only check my answer if I had extra time, because that's going to take me an extra minute on the test. I might not have an extra couple minutes on every single problem to check. Okay. Okay. Any questions on writing your answer either way? Both ways are correct. Right. Let's try this one. So what's the first step you'll always have to do, even if they've already done it for you here? Which they have in this one. Yeah.
0x to the n that's missing.
Yeah, fill in any terms that are missing. So the highest is a degree 4. So you've got to have the 3, the 2, the 1, and the constant. All of them. Can't be missing any of them. So we've got the 4, the 3, and the 2 and the 1 have been filled in for us. Okay, so Chris, what's going to be the first thing that I divide into the first thing? Like what divided into what?
First term, so 2x 4.
2x to the 4th is going to be divided by
2x squared.
Yep, good. That's what you're doing in your head off to the side right now. We're going to put the answer up top. What's 2x to the 4th divided by 2x squared? Yep.
The x squared.
Just x squared. Multiply that x squared back out. This time you've got 3 things. That's a trinomial, so you got to do 3 multiplications. 2x to the 4th plus x cubed plus x squared. And Elias, what am I doing with all those columns now? Yep, I'm going to subtract them all. Got to remember to subtract them all. Okay? And if you don't get something that cancels it, you made a mistake. 2x to the 4th minus 2x to the 4th, gone. Emily, what's negative x cubed minus x cubed? Negative 2x cubed, yeah. And then 0x squared minus x squared is that. And now bring down your next term. I mean, the next term is just a 0, but if it helps you, yeah, I would just bring it down. Okay. And now we divide the first term on the outside again into the first term here. So Sam, when we do negative 2x cubed divide by 2x squared. What do I get?
Negative x.
Good. Negative x times positive 2x squared, negative 2x cubed. Negative x times positive x, negative x squared. And Caleb, negative x times 1,
Negative x.
just negative x.
So you divide that first number into the, or
Yeah.
divide the first number by.
Divide, yep, the first term here by the first term over here. Okay, and now we're going to subtract and see what happens. How about, Brianna, what's negative 2x cubed minus negative 2x cubed? 0x cubed, it's gone. Brandon, what's negative x squared minus negative x squared?
0.
0, it's gone. So remember I told you sometime your exponent will drop 2? This one's going to drop 2 at the same time. And we're going to be done now at this step. Zach, 0 minus negative x is x. The only thing left is to bring down the 2, but you're done because look at the degree here. That's a degree 2. What's the degree of my remainder right now? So what's the degree on all of this? The degree of that polynomial.
1.
That's a degree 1. It's a linear polynomial, degree 1.
So is it less than or equal to?
It is less than. Nope, not equal to.
So if the degree up top happened to be 1, you would just keep going?
Yeah, if this degree, like let's say this part wasn't here, and that was your problem, all that work would be wrong. But you wouldn't be done yet because that's a degree 1, that's a degree 1, you gotta go one more step.
Okay.
Yep.
So you could end up with no x down here.
Yeah, that's exactly what happened here.
Okay.
Our remainder was,
Oh, yeah.
our remainder was just, I think, the number 6.
Yeah.
Yeah, there was no x.
I don't know.
Yep. Okay, so now that we've done that, we're done. So my quotient is x squared minus x, and my remainder is x minus 2. I am not going to write this problem both ways. I'm just going to put the answer like that. So when we started this one, to me, it looked like this problem was going to be worse because it was bigger, but actually the numbers worked out nice. You got 2 things to cancel in the second round of division, so you're done. The further apart this number and this number are, the longer it's going to take. Right? Like if this number on the inside was like a 12 and this number on the outside was like a 2, it's going to take forever. Okay? Unless everything cancels real nicely. But in general, I mean, you saw 2 and 4, that's only 2 apart. 1 and 3, that's only 2 apart. So in general, I'm going to try to give you ones where the exponents aren't that different. Otherwise, it takes too long. All right, so I'm going to write something down. It's probably going to look a little confusing at first, but I'm going to show you numbers, just like I've been doing, and it'll make sense after that. So let's say you have 2 polynomials, f of x and h of x. Okay, f of x, and you're dividing it by h of x. When you divide them, you are going to get a quotient, and you're going to get a remainder. Such that, and I'm going to write down something we've pretty much been writing the whole time. Okay? It's the other way you can write your answer, besides putting like a Q and an R. Anyone remember that little formula I showed you in example 1? You could write your answer as what plus what over what. Yep. Quotient plus remainder over the original divisor, which you divided by, was h of x. All right? So, you know what? Let me write that on a separate page for a second, because I need a little space. So if you divide this by this, you will get a quotient, you will get a remainder, and you have original denominator. Any question on that formula? I'm basically going to write this formula a little different, but I'm basically going to write the same thing. Let me show you. If you look at that at first, you might be like, huh? That's not the same thing he just wrote. Yes, it is. It's the same thing. So this says f of x equals h of x times q of x plus your remainder. Now, let me go back to the formula on the other page, and I'll show you how it's the same thing. The formula that I just wrote down had this by itself. How would you undo dividing by h of x? Yeah?
Multiply by h of x.
Right, and you have to do it here and here. What happens on the right-hand side when you have an h of x in the bottom and an h of x in the top?
Cancel out.
That cancels right out. Look what you're left with. And you multiplied by h of x here. So you multiplied by h of x in all three spots. You're left with f of x equals your quotient times your denominator plus your remainder. The formula that I've been giving you since example 1, this is exactly the same thing. It's just rearranged a little bit. It's like in Algebra 1, you learn this formula, distance equals rate times time. Well, that's the same thing. All you did was take what you already knew and you just moved some stuff around a little bit, right? But that's all I did here. This is the same formula. Let's look at it with numbers. Let's say we took 17 and we divided by 5. Let's figure out the quotient and remainder and then see if this all actually works. What's the quotient when you divide 17 by 5? Anyone?
3.
3, thank you. And what's the remainder? 2. So let's try this formula. We just did 17 divided by 5. So 17 equals 5 times the quotient plus the remainder. Does 5 times 3 plus 2 give me 17? Yeah. So I'm just showing you how it works with actual numbers. So that's just a fact that's always true. Okay? And that's how you probably check your answer when you do long division. Like back in like 3rd or 4th grade. Take your quotient times your denominator and add your remainder. If you get your numerator, then you did it right. If you don't, then something's wrong. So I'm going to show you guys next what's called the remainder theorem. I don't know why, but a lot of people forget this theorem on the test. I even write on the problem on the test, hint, use the remainder theorem. And they don't use it because I don't think they remember it. But the remainder theorem gives you a quick way to find a remainder. That's all it does. It doesn't give you the quotient. If you want the quotient, go back and do all the stuff that we just did. But if all you want is the remainder, there's a quick way to find it. Now, I say there's a quick way as long as you're dividing by something specific. If you've got a problem, let's call this f of x, and you divide by this. Could be x minus 2, could be x minus 7, could be x minus 12. Important thing is, there's a number there. If you take that number and you plug it into the top, it automatically gives you the remainder. It's like a special trick. We don't really go through the proof of it in here. I did last week. It's not that bad, but it's not really something I want to focus on. So the trick here is if you divide by x minus a number, all you got to do is take the number that would be in that box, plug it into the formula in the top, and you will automatically get your remainder. That's what this is saying. Plug this number into the formula, and that is your remainder. And does anybody remember from earlier why we might want to find a remainder? If a remainder comes out to something special, it tells you something. Does anyone remember? If your remainder comes out to what?
Comes out to 0.
Yeah? What does that mean? If you divided two things, you've got a remainder of 0. It's a factor. That's the whole point of this theorem. If you divide two things and get a remainder of 0, then you know you have a factor. So this is a quick way to basically check if something is a factor. So let's check for the remainder here. So 2 parts. It says find the remainder when you divide f of x by h of x. And then find the remainder again when you divide f of x by g of x. So let's start with f of x divided by g of x. And we're finding the remainder. I'm sorry, we're going to do g of x second. We're doing h of x first. Okay. Is h of x set up to be the kind of polynomial that I just said you needed to have? So I said you can find the remainder as long as you divide by something that looks like this. Does h of x look like what I said?
Yeah.
Yes, it does. It is of the form x, wherever I had it, x minus a number. So what is the number that we are dividing? Or what is the number here?
3.
Careful, remember you're just looking for what number would be in that box.
Oh, 3.
3. Okay, a little tricky. Just the number that's in the box. 3. Plug that in for x, and you will know your remainder. Okay? When you divide by x minus 3. So let's see what we get. F of 3. Okay. What's 3 to the 3rd power? That's 3 to the 4th. Yep. 27. Make sure you follow PEMDAS. 3 to the 2nd power? 9 times 2?
18.
So we're subtracting 18. Plus 3 minus 5. Okay, so let's see what we get. Let's just type it all in. So you got 27, oops, 27 minus 18 plus 3 minus 5. Calculator will handle PEMDAS because it knows how to do that. And I get a remainder of 7. Okay, so great, I get a remainder of 7. But what does that mean?
It's not a factor.
That means that x minus 3 is not a factor of this. So if you were trying to factor f of x, by making sets of parentheses, x minus 3 isn't what you should use. What should you use? We're not worried about that yet. But you shouldn't use that. Okay, let's look at g of x. Let's do f of x divided by g of x. Now, is g of x set up the way I said it had to be to find the remainder?
No.
Not quite, but you can make it so it is. Remember, you have to divide by x minus, and you have to have something in that box. What would go in the box here?
Negative 1.
-1. Now you are dividing by x minus a number. It's x minus -1. So -1 is what now you're going to plug in. Any questions on that? Okay, if this was like x squared or x cubed, this trick doesn't work at all. This trick only works if it's x minus a number, or technically x plus a number, because you can make it x minus a number. But it's got to be x minus a number eventually. Okay? Okay, let's plug in -1 and see what we got. Okay, what is -1 cubed? Yep. So we get -1. -1 squared times 2. So we're minusing 2. -1 minus 5. -1 minus 2, that's going to give me -3. -1 is -4. Minus 5 is -9. So you found the remainder. If you were to do out all the long division like I showed you, that's what you'd get for the remainder. So what that means again, g of x is not a factor. It's not a factor. You don't have to write that here, but that's what we just figured out. Okay, and that's called the remainder theorem. So the factor theorem basically it's very similar to the remainder theorem. Okay, it says that if you divide by x minus c and you get a remainder of 0, that means it's a factor. Well, it actually means two things. So if you have a polynomial, you divide by x minus c. Let's call this polynomial f of x. To find the remainder, this is how you do it. You take this number and you plug it in right there. All right? Plug c into your function, and that gives you a remainder. Now, if you plug c in to your function and the remainder comes out to 0, what does that make the number c automatically? It makes it a 0 or a
Factor.
what's the other word for 0?
Root.
Root, right? If you plug a number into a function and get 0, that number is called a root. Well, this also happens to give you the remainder. So it actually means two things. If you plug in c into your function and you get 0, well, that's your remainder. That's what I just taught you. And if you plug c into your function and you get 0, we learned last week that that's called a root. So there's actually two separate things happening there. But they go together. So now you've got another thing that means the same thing. If c is a root, then c is a 0. That also means that you just found a factor. That's the new piece. You just figured out a factor. Okay, that's important. So, they want us to use the factor theorem, which basically means find the remainder and make sure it comes out to 0, to prove that x plus 2 is a factor. Now, the long way to find out something is a factor, do the long division. Take this and divide by this. That'll work. You can do it. It's going to take a lot longer. Or, what number can I plug into the top and quickly get the remainder? Be careful.
2.
-2. Right? You've got to divide by x minus a number, not x plus. So plug -2 into the top, and let's see if we get a remainder of 0. And if we do, then x plus 2 is a factor. So we're going to get -2 cubed. 5 times -2 squared. 5 times -2 minus 2. could double check, make sure I didn't mess up. Negative 2 cubed is negative 8. Brianna, what's negative 2 squared? 4 times 5? 20. And Brendan, what's 5 times negative 2?
-1.
And Eric, we just have the minus 2. What's negative 8 plus 20?
12.
Yep. And then now I can see it. 12 minus 10 is 2. 2 minus 2 is 0. We're good. We just proved that if you divide it in, you get a remainder of 0, which means it went in evenly. So that is a factor. So, if you were trying to actually factor this problem, x plus 2 is a factor. How do you get the other factor? This is what you have to do. This is like if I said to you, factor the number 12. I'm telling you 3 is a factor. How do you get the other one? Yeah.
You divide the equation by x plus 2.
Yeah. You divide out by x plus 2, and you'd look for the quotient. In this case, it would be 12 divided by 3 is 4. I can't do this other one as quick in my head. But whatever you got for a quotient when you did long division, it would be a quadratic. It would be an x squared something. Okay? I'm not worried about finding the quotient right now. I don't want to do that. But I'm just telling you, you could. Any question on that? So it's like we're kind of using the same thing over and over. We're just using it to kind of figure out different things. Remainders, factors, it all kind of goes together. Okay, so here's some equivalent statements about factors and roots. For factors, zeros, roots, all that stuff. If you have a number c, right, and it's a solution to this equation, it means you can take c, you can plug it in for for x, and you get an answer of 0. Any number that you can plug in and get an answer of 0 is called a 0. And I just asked Jared this. What's another name for a 0? A root. If you have found a number that you can plug in and get 0, it's also called a root. I think I asked Zach this one earlier. Graphically, if you have a root, that's where your graph does what? Think about if you have an x value of 0. I'm sorry, a y value of 0. That's what?
X-intercept?
That's an x-intercept. That's actually the last one I wrote. This is the one that's probably the most important. That's the new thing we just figured out. If you have found a number that is a root, x minus that number is a factor. Why? That's the factor theorem. So, when I gave you guys the factor theorem, I didn't mention it again, but it had that IFF in it. If and only if. Okay, I'm going to go back to that for 1 second. Right? Right. Wherever we had the factor theorem, somewhere. Right here. If a number is a root, then x minus that number is a factor. That's very important. If a number is a 0, x minus that number is a factor. So for the last problem, you're gonna need that. Okay, so I think we got two examples left. This last one? So that last thing that I said is basically this, right? If you have a number that is a root, okay, let's say if 2 is a root, then x minus 2 is a factor. And that's important because in the next problem, I'm going to give you a problem with roots. I'm going to say, here's 3 roots. Tell me the polynomial that they came from. You're going to have to work backwards and figure it out. Okay? I'm not going to give you a polynomial and say, okay, you figure out the roots. I'm going to tell you the roots. You tell me the polynomial. So, I want you to find a 3rd degree polynomial where the roots of it are -2, 1, and 3. Let's start with the -2. So I'm telling you that -2 is a 0. That's what it says in the problem. Based on that page I just had up, can somebody tell me what else that means about -2? If -2 is a 0, then -2 is also what?
X minus C.
Okay, what do you mean? So this is like your C. So I'm telling you a specific value of C that works. -2 is a root. So what else does that mean? So my C in this case is -2. -2 is one of my zeros. I mean, there's 5 other things you could say, but I'm looking for you to say one of them in particular. Yeah?
This is a solution for f of x.
Okay, so -2 is a solution that if you plug it in, you will get 0. Yes. But you don't know you don't know this yet. This is what I want you to figure out. What do you plug it into? So what else does it mean? -2 is a 0, yeah?
It's a factor of x.
Can you say that more specifically? What is a factor? I want to know exactly what is a factor. -2 is the root. So what would be a factor? Yeah?
X plus 2.
Yes. If you know that -2 is a root, you know that this is a factor, which Jerry wrote as x plus 2. Let's do it again. What if 1 is a root? What else do you know?
X minus 1 is a factor.
Yes. And what if 3 is a root?
X minus 3.
Is a factor. Yep. So now we've got x plus 2, x minus 1, x minus 3. Let's FOIL that out and see what we get. So we get x squared plus x minus 2. You can double check me on that. And then FOIL that out to x minus 3. So we're going to get x cubed, x squared, minus 2x, minus 3x squared, minus 3x plus 6. Okay, when I combine like terms there, can someone give me my final answer? That?
X cubed minus 2x squared minus 5x plus 6.
Okay. Let's check it. Let's draw that on the screen. And if we did this right, it should cross the x-axis at -2, 1, and 3. Perfectly. Okay. So this is how I would make a test question. If I already knew what I wanted the answers to be, I would do this. And now I would give you what's circled and have you work backwards and get the roots. I haven't taught you that part yet. That'll be later in the week. But let's check it. Also, x cubed minus 2x squared minus 5x plus 6. Does it look like it crosses exactly where we want it? -2, 1, 3? Yep. Perfect. Okay. So that's the thing you have to remember. If you've got a number that's a root, x minus the number is a factor. Okay. and this is our last one. Even though it's a cubic, it's going to be very easy to solve for the roots, because I told you I'd show you later in the week how to solve more like complex ones. This one's not complicated. And I'm giving you a hint. Use factor by grouping. So factor by grouping means factor what you can out of the first two, then factor what you can out of the second two. So who can tell me what these first two terms have in common? Yeah? Even more. More than 1x. You can factor out more. You can factor out x squared. If you factor x squared out, what are you left with in the parentheses?
X plus 2.
Right. Now the goal is to get x plus 2 again over here. That's how factor by grouping works. Does anybody see what I could factor out of this part? Factor out a -4, and look what you're left with. If you didn't get x plus 2 twice, this wouldn't work. Now, you factored out what those had in common. Now look at this, and look at that. What do each of those have in common?
X plus 2.
Right, this is where factor by grouping works. If you had an x plus 2 and an x plus 3, you're stuck. You've got to have the same thing. So now you factor out the parenthesis. If you factor out the x plus 2 from the first one, what's the only thing that's left? Just the x squared. And if you factor the x plus 2 out from the second part, what's the only thing that's left? -4. Now you've got something times something equals 0. What's the only way you can multiply two things together and get 0 as the answer?
1 of them equals 0.
Exactly.
1 of them is 0.
Yeah. Either this one or this one. So, what would you plug in for x to make the first one 0? Yeah. Yep. So we get -2. Solve this one. What would you plug in for x to make the second one 0? Be careful here. What do you basically have to find here? The what of 4? The square root. What is the square roots of 4? 2?
-2.
-2. Now you might be saying, well, what's the big deal? We already got -2. Yeah, we were lucky. -2 is what we call a repeated root, which means if you were to graph this cubic, it would look something like this. It would not cross the x-axis 3 times. It would come up and touch it at -2, and then it would cross over here at +2. If it went through and crossed it like that, then you'd get 3 different answers. But that didn't happen here. That happened. Okay? So when you're asked for the roots, all you'd have to do is write +2 and -2. You don't have to write the same answer twice.
How did you get from the x squared time, like the parentheses, to the next step?
So we factored the x plus 2 out of here, because whatever they have in common, you take that and put it on the outside.
Okay.
That's just like here.
Oh.
You said they had an x squared in common, so we put that on the outside. What do these have in common?
I see what you did now.
This and that goes on the outside, and then whatever you're left with is what you put here. X squared and a -4.
Okay.
Okay. So later in the week, we'll look at ones that don't factor by grouping, and I'll show you how to do them. I'm also going to show you a better way to do division than what I showed you today. Okay, I'm going to show you synthetic. Now you might think, why didn't you just show us the better way to begin with? Because the better way doesn't always work. Okay, the way I showed you today will work all the time. The better way is faster when it works. Okay, so we'll look at that tomorrow. Okay, so that's homework tonight on page 171. So it's 1, 2, 4 through 6. 9, oh, I skip 11. So 9, 13, 15, 17, 19, and then 20, 25, and 32. So we'll take a look at that tomorrow, and then tomorrow is already the second to last day of new material. This is a short period.